Hello everyone, welcome to this third video on complex integration. We have been doing problems under Cauchy integral formula and Cauchy formula for derivatives. We'll continue on the same track in this third video too. We'll evaluate the value of integral over c 3z square plus z by z square minus 1 dz, where c is going to be the circle mod z minus 1 is equal to 1. So the first point is to recollect the formula. The formula for Cauchy is given by f of z by z minus a dz is 2 pi I into f of a. Now we can see that what we have in the integral in the denominator is z square minus 1. How I can rewrite this as? I can rewrite this as a square minus b square. So it is a plus b z plus 1 into a minus b z minus 1. So my integral over c, now 3z square plus z, now in the denominator takes z plus 1 into z minus 1 into dz. This is what I will have to evaluate it for. Now point number 1 is always to try to get the singularities or the poles, which is given by denominator equated to 0. Z plus 1 equal to 0 gives z is equal to minus 1, power is 1, so is a simple pole. So this is going to be a simple pole. What is the second thing? Z minus 1 equal to 0 gives z is equal to 1. This is also of power 1. Therefore, this is again a simple pole. So what we have is going to be two simple poles. One with z equal to minus 1. The other one is z is equal to plus 1. Point number 1 is over. What is going to be point number 2 is to plot your region or boundary. What is going to be the region? Mod z minus 1 is equal to 1. Now we will see what is this mod z minus 1 equal to 1. What is modulus of z? So z is nothing but x plus iy minus 1 equal to 1. Now this is a real number, this is a real number. Let me combine the real number as x minus 1 plus the complex number iy equal to 1. Now how to remove the modulus? It is square root of real part square x minus 1 the whole square plus imaginary part square. So y square is equal to 1. In order to remove the square root, I square on both sides. Squaring on both sides gives me x minus 1 the whole square plus y square equal to 1. I can very well rewrite this as x minus 1 the whole square plus y minus 0 the whole square is equal to 1. Now you can identify this with the general formula for a circle as x minus a the whole square plus y minus b the whole square is equal to your r square. In which case, what is in place of a? I have the place of a to be equal to 1. What is in place of b? I have the place of b to be equal to 0. So the center is given by a comma b, and now in this case the center is given by 1 comma 0. And what is going to be the radius? Radius is given as r, and what is going to be r over here for us? Radius r is going to be equal to 1 units for me. So what I need is going to be a circle with center 1 comma 0 and radius is equal to 1 units. Now come on, let us try plotting it. Now this is going to be my circle with center 1 comma 0. So this is going to be my center with circle with center 1 comma 0 and radius 1 unit. 1 unit from 1 to 1 will make it as 2. Over here to the left will make it as 0. So you are going to draw this circle. What is going to be my point number 3? My point number 3 is to identify the position of the poles. What is the position of the poles? Z is equal to minus 1 and z is equal to plus 1. I'll have to identify the poles where they lie in this given region or boundary for me. I can write this as minus 1 plus I0, in which case my x comma y will be minus 1 comma 0. I can write z is equal to 1 as 1 plus I0, in which case my x comma y will be equal to 1 comma 0. So I'll have to now plot my points. What is going to be given as minus 1 comma 0 and 1 comma 0. Where is going to be my point minus 1 comma 0? My point minus 1 comma 0 will be identified over here, minus 1 comma 0. So this is my point, minus 1 comma 0. What do you think is going to be the position of this point? This point just z is equal to -1, which is -1 comma 0. Where is it lying? It is lying outside the given circle. What is going to be the circle? Mod z plus 1 equal to, sorry, z minus 1 equal to 1. Okay, so now I have the quantity first pole z equal to -1 to lie outside. Now we will check with the second pole. What is going to be the second pole for me? Z is equal to 1. Where is my point 1 comma 0? Here is my point 1 comma 0. Where do you think this is going to lie? This point is going to lie inside my circle, which is going to be mod z minus 1 equal to 1. So out of the two poles, one of the pole lies outside and one of the pole lies inside. Now what we have for the problem is integral over the curve C. What was your function? 3z square plus z, 3z square plus z divided by z minus 1 into z plus 1 into dz. This is what I will have to evaluate for. Now identify it with the given formula for Cauchy. F of z by z minus a dz 2 pi I into f of a. Now we know that here in the denominator this is going to be the pole that lies inside. So which is going to lie inside for me? Under the both the categories, z is equal to 1. So z minus 1 lies inside. And what about the other quantity? Z plus 1 lies outside. So which lies inside? Lying inside is going to be just the point which is going to be lying inside, z minus 1. So keep this z minus 1 over here. And what you do is you take the other quantity z plus 1 along with your numerator so that you can club it with your numerator and write it as 3z square plus z by z plus 1. Now why is that we are taking one of the factor above and keeping only one factor below? Now you see, when both the factors are lying in the denominator, they are in product, and so we will have to apply partial fraction method to split them into two parts. Now applying partial fraction is going to be very hard. So how can that be made easy? The point that lies outside can be clubbed with your numerator so that this becomes your numerator. So what happens to my numerator now? It becomes 3z square plus z divided by z plus 1. So keep in mind, whenever you have factors that lie outside can be clubbed with your f of z, leaving just the poles that lie inside in the denominator. Now this quantity is going to be 2 pi I times f of a. What is going to be my f of a? My point a is z minus a is equal to z minus 1. So my a is equal to 1. What I need is f of a. What is going to be my f of 1? So 3 into 1 plus 1 divided by 1 plus 1. So 3 into 1 plus 1 makes it as 4 by 2. So that makes it as 2. So I have 2 pi I into f of a. What is this f of a replaced as? It is replaced as 2. Hence the final value for your integration will be 2 pi I times of 2. Hence the final answer becomes equal to 4 pi I. Oh, what is going to be the takeaway from this problem? Whenever we have factors in the denominator as products, the quantities that is going to lie outside can be clubbed with your numerator, which is f of z, to form a different function f of z, and just keep your quantity that lie inside in the denominator so that the poles can be evaluated for. This will avoid the task of partial fraction method. Thank you.